SARS-CoV-2 presents a unique challenge to humanity. The virus causes COVID-19, a fatal respiratory illness that has affected more than 8.2 million individuals worldwide, including 446,000 deaths. Now, what does coronavirus look like? The name of the virus comes from the configuration of the surface proteins. The spike, or S proteins, give the virus its crown-like shape and is the virus's entryway into the body. The cells of our lungs, kidneys, and livers have an enzyme receptor called angiotensin-converting enzyme 2, or ACE2. Typically, these receptors assist in the angiotensin-renin pathway to regulate our blood pressure and oxygen intake. However, the S protein of coronavirus attaches itself to these receptors and cleaves them, forcing its way into the cells. Once inside, the virus is able to incite a series of inflammatory immune responses, leading to the symptoms we see in COVID-19 patients. So how can we fight the virus? Scientists are scrambling to find a cure, among which include monoclonal antibodies. Monoclonal antibodies are essentially specialized synthetic immunoglobulins, or antibodies. These antibodies are created to recognize a unique epitope on a specific antigen. Monoclonal antibodies are created using the hybridoma technique developed by Drs. Euler and Milstein in 1975. This technique combines the plasma B cells, which can produce the specific antibodies, with myeloma cells, or cancer cells. Myeloma cells are fast-growing and cannot produce immunoglobulins of their own. Combining these two cells gives us fast-growing and specific antibodies. So why does this give us hope for the virus? If we can create monoclonal antibodies to bind to the S protein antigen on coronavirus, we can stop it from attaching to the ACE2 receptors and initiating the inflammatory response. We can think of the coronavirus as a home invader and the S protein as a fake key. We can also think of the monoclonal antibodies as a key cover to stop the counterfeit key from going into the lock. Currently, scientists have succeeded in creating preliminary monoclonal antibodies from animals and are now developing this technique to be adaptable to humans. Scientists hope to create antibodies that can not only prevent infection, but can also prevent against reinfection, providing the human body with the necessary antibodies to protect against the virus. These antibodies might just be the lasting cure to save humanity.